Hello and welcome back to the RPA Developer Training. Now that we've learned what selectors are and how they work, we can proceed to a more in-depth demo of the UI Explorer wizard. This is one of the most frequently used tools in UiPath Studio. In the previous lesson, we've discussed some scenarios in which the selectors generated by UI interaction activities might not be reliable in the long run. Now, we'll see how we can adjust the automatically generated selector attributes to ensure that our selectors are stable and adaptable to as many situations as possible. We've already created a new project, so let's open the UI Explorer wizard. UI Explorer is an advanced tool that enables us to create a custom selector for a specific UI element. Let's see it in action. We'll indicate the Cache In field in the UI application. Let's click the Indicate Element option and select the field that we're interested in. Now, we can see not only the automatically generated selector for the input field, but also the entire visual tree of the application that we're automating, with all of its nested containers. Moreover, we have the option to check whether the generated selector corresponds to the correct field by clicking the Highlight button. The visual tree also has a highlight feature. If we enable it and browse through the containers below, the UI elements of the application are highlighted as we're selecting them. The central panel displays the position of the input field within the UI hierarchy. Each line displayed here is called a node. The first node corresponds to the application itself, and the next ones match the different nested containers. The element that we selected is defined by the final node. If the selector doesn't identify the correct element, one of the courses of action available to us is to switch to a different UI framework by clicking the UI Frameworks button and selecting one of the three options that are displayed. After we change the UI framework, we need to indicate the element again for the selector to be updated. We can try out all of the options and pick the one that returns the most accurate selector. The Selector Editor panel displays the selector in two formats. We can see the raw selector in the top part and the optimized selector below. Optimized selectors usually consist of the first and the last nodes, which, in most cases, are enough to identify an element within the application. The raw selector can be extremely intricate, but we can freely enable or disable the nodes in the hierarchy as needed. To make sure that an element is successfully found, we can make the selector more specific by increasing the number of nodes included in the refined selector. The optimized or final selector is a standard XAML fragment containing the various nodes and their attributes. Most often, when selector errors are thrown, we need to edit the attributes and match their values to the ones in the application that we want to automate. We can also check or uncheck the attributes in the raw selector to make it more specific or generic, depending on the case. Let's test what happens if we enable the text attribute and use this selector in an activity. To do that without generating a new selector in the activity, we can copy the one displayed in UI Explorer. Next, we'll add a type into activity and go to the selector field in the Properties panel, where we'll simply paste the selector as a string. Note that the selector property only accepts input of type string. If we open the selector editor, we can see that it's automatically recognized and converted. Let's provide a number for the text property of the type into activity. Let's say 34. Now we can run the project. As we can see, it wrote the new string next to the existing one. If we don't want that to happen, we can go back to the Properties panel and enable the Empty Field option. OK, let's try to run the project again. The execution failed this time. Can you tell why this happened? Our selector includes the text attribute, which contains the $12.00 value. At runtime, the value of the text attribute was $34.12.00. This is an example of a selector that's too specific and only works in a particular case. To fix this, let's take a look at a different tool, the Selector Editor. We can access it from the Activities Edit Selector option or by clicking the Expression Editor button for the selector property. It's similar to UI Explorer, but it includes only 2 panels. The first one contains a list of all of the attributes of the nodes that form the selector, and the second one displays the used selector. As we've previously seen, the current selector is invalid. To fix it, we can deselect the text attribute. When we click the Validate button, we can see that now it looks fine. To open the entire attribute list, we can easily access UI Explorer from the Selector editor. Okay, let's run the project again. Great! It worked as expected. And that was all for today. For a quick recap, UI Explorer lets us create a custom selector for a specific UI element. The Visual Tree panel displays a tree of the UI hierarchy and enables us to navigate through it by clicking the arrows in front of each node. The Selector Editor panel displays the selector for the specified UI object and enables you to customize it. The bottom part of the panel displays the actual XAML fragment that we have to use in a project. The top part of the Selector Editor panel enables us to view all of the nodes in a selector and eliminate the ones that are not necessary by clearing the checkbox in front of them. The Selector Editor tool is very similar to UI Explorer, but it contains only 2 panels. Thanks for watching and happy automation!